Now, I wanted to go to the internet and I just want to show you some of the data that's out there. So if you actually type in a Google search and look for silly correlations or funny relationships that occur in correlations, you'll see lots and lots of websites that have these interesting graphs in them. So they've actually taken real world data, compared them, and went, oh my, there's a pattern there. But as we look at the data, you'll kind of go, yeah, that's not connected. There's just a coincidence there. So, for example, the divorce rate in Maine seems to behave much similarly to the margarine consumption in the United States. Not quite sure how a divorce rate controls or predicts who's getting divorced, but seems to be an odd relationship over the past 10 years with that. Bedsheet deaths and ski profits. So the number of people who die because they're tangled in their bed sheets versus how much money total ski facilities make. Again, I don't necessarily know why those are connected. Norwegian oil and train accidents. So apparently getting in U.S. crude oil imports and drivers killed in collision from runaway trains. You can clearly see there's a pattern. Don't know why those are connected. Miss American murder. So, if you look at how old Miss America is versus murders by steam, hot vapors, and other hot objects, you can see some sort of defined pattern. So, going back to our notes, just because we see a relationship of some kind doesn't necessarily mean that there's a cause and effect going on. So, let's give us some guidelines so that we can make sense of all this craziness in the world. To investigate whether a suspected cause activity actually follows effect, we want to consider the following ideas. So number one, look for situations in which the effect is correlated with the suspected cause even while other factors are taken away. In other words, consider all factors. Maybe there is another external factor impacting the relationship that we just don't see. Number two, check that the effect is similarly present or absent among groups that differ only in the presence or absence of the suspected cause. So if there is a pattern, then all subgroups should also have that pattern. So when we start sorting data and look at subgroups, we should see a similar type pattern if it is in fact cause and effect. And if not, then maybe there's something about the subgroups that can control that. So I'm going to write that. Consider subgroups of the data. Number three, look for evidence that larger amounts of the suspected cause produce larger amounts of the effect. In other words, if we add more data values, we should see more of the same effect impacting things. Some of those graphs that we looked at a second ago, there wasn't that much data to begin with, so that might have been a special case. But in other words, if we add more data, effect should still be present in a larger amount. Okay, number four, account for other potential causes. Maybe there's some other reason why what we see is what we see. Or maybe there's something else that's controlling it. Number five, test the suspected cause with an experiment. So sometimes the data isn't really a controlled experiment. So if we want to really check and see that it's viable, we want to go out and conduct an experiment in the real world. And then number six, try to determine the physical mechanism by which the suspected cause produces the effect. In other words, there's got to be a good reason why one thing influences the other. What is the mechanism that is controlling A to B? Now, let me finish writing this out. There's a mechanism that controls the two variables. So, in other words, in a good cause and effect relationship, we should be able to see, we should be able to describe why. Why is this, like the divorce rate and margarine example, why would margarine consumption have to do with the divorce rate, I guess? And if we can't answer that question, then chances are there is no defined relationship, or maybe we just need to go investigate it further. So again, these are guidelines. These aren't set in stone. These just kind of help make sense of the world around us. An example, by the mid-1990s, passenger airbags had become more commonplace in cars. Statistical studies showed that the airbag saved many lives in moderate to high-speed collisions. But a disturbing pattern also appeared. In at least some cases, young children, especially infants and toddlers in their car seats, were killed by airbags at low-speed collisions. Okay, so what should we get away from this evidence? What should one take away from this? So when I first read this, when I first saw this, I kind of want to confess my age. I'm old enough that I remember being in a car without a car seat. And I remember being in cars without wearing a seatbelt, and no one got pulled over, and no one, broke the law in that case. So something must have happened. Something happened between that mindset of no one wore their seatbelt to nowadays we've got rules about where kids can sit, and we've got airbags in all these cars, and how does one go from point A to point B? How do we get there? Well, obviously someone had the bright idea about airbags, and the thought behind airbags is it would save lives, but they didn't necessarily recognize all the consequences of airbags when they first implemented out and rolled it out. Unfortunately, certain decisions they have to gather data on and then realize, hey, we might have made a mistake and we need to change some policies and procedures. So when airbags were first coming out in the early 90s, there were no restrictions on where kids could sit. Nowadays, because I've got a couple small kids at home, my wife reminds me that certain children can't sit in certain seats until a certain age or height or weight. And there's all these rules about when it's safe for kids to sit up in the front seat versus they have to sit in the back. And that stems from this type of data that was collected. And so what they found is, yes, you put a kid in a car seat, that tends to save lives. But when you mix it with an airbag, especially if you let the kid sit in the front seat, that sort of creates a punching bag scenario where the kid is that perfect height that they get a lot more of the force of the airbag than a normal adult would because we're just sitting taller. And they went out and they tested it with dummies, and they found that, yeah, that's true. And so as a result of that, we now have rules that say up to a certain age, the child's going to be in the car seat, but they're supposed to be rear facing. And then after they get a certain height, then you can turn them around and let them be front facing. And then when they get old enough, they can get off the car seat into a booster seat, and then booster seat into a normal seat, and then I believe early teens, they can start sitting in the front. In case you didn't know that, there were rules about that. And that stems from this type of situation where they gathered data first and then realized that there was a problem with the types of policies that they were implementing.